Hello class, welcome back to system programming. It's been a long time since our last class, right? Yeah. Okay, let's get started. So today is 8th May and we're gonna start operating system overview today. And before check your attendance, I have a few announcements. Firstly, please keep the evening time of June 19th available. We will take final exam on June at 19th from 6:30 p.m. to 8 p.m. Yeah, and if you cannot make your time at this time, please contact me by email. And so, did you enjoy your midterm exam? No? I think it was not quite difficult, isn't it? Wasn't it? Okay. I have a typo. The midterm exam is still being graded, and I will announce your grade next Monday, 11 May. And I have one more announcement. So on April 28th, we covered this thing, some topics from the missing semester of your CS education. It would be very beneficial to go through all these contents before your graduation. So I think about 5 or 10 students came to the class at April 28th, but if you didn't take the course before graduation, I highly recommend you to go through all these contents before your graduation. This content is really good. So I think you can go to this link and you can study by yourself because they saw some very good video lectures. Okay, then I will check your attendance. Okay, let me check your attendance. Silva, 윤민성, 모, 티키나스, 루카스, 조윤솔, 이수민, 레오, 실파, 오렐리, not here, 김민성, 표, 노연우, 윤아라, 이강민, 완, 한채영, 루슬란, 베네딕트, 안현식, 아므리나, 차승호, 조은재, 이동훈, 네이선, 하미마, 정준희, 이재준, 김동현, 둔, 이민훈, 송민혁, 강희진, 손아현, 김예원, 박승빈, 최지원, 나미, 찬, 김다희, 김민채, 강한결, 전영재, 이주호, 알반, 방채진, 박희현, 강민수, 슈디, 김현중. Okay, did I miss anyone? Okay, no one. Okay, then let's get started. Before start the lecture, I want to apologize that today I failed to manage the amount of the material, so this class will be ended earlier than usual, so maybe about 50 minutes or 40 minutes, but I think it's not, it will not be a problematic because we have plenty of time to cover all the topics. Okay, then let's get started. Before the midterm exam, we covered, we learned about the core system software ISAs, which is called SIC, right? And after the midterm exam, we will learn about basic concepts of operating systems, like process management or input and output device management. Okay, let's see. Before the midterm, we used the textbook, which is title was SIG or something, system program, blah blah something. But from now on, you don't have to check that textbook. From now on, we will use this textbook, operating system concept. It is one of the most famous operating system textbook. We also have other OS textbooks such as 3 Easy Pieces, but in this class we will use this book. This one is very famous in South Korea, so we usually call this book 공룡책 in Korean, maybe dinosaur book in English. And in my opinion, you can easily find the PDF file of this textbook, so I don't recommend to buy this textbook, but you can buy it if you're rich. Okay, then so during this class and next class, we will cover the concept of the operating system and their services and operations. And in the next class, we will learn about system course. So, in my opinion, maybe most of you already have heard about some concepts of the operating systems, right? So what is an operating system? It's a program that acts between applications and computer hardware. So we are the computer users, right? People. And other computers also can be users. And they want to solve some problems by using the programs or applications. So the programs will solve some computing problems by using the computer resources. And we have some hardwares and resources which provide some computing, provide some computation powers. And the operating system is lie between the user programs and hardware. So the operating system is a kind of a manager. So it will control and coordinate the use of hardware among various applications and users. So the goal of the operating system is provide an environment where a user can execute and solve some problems easier. So the operating system will make the computer systems convenient to use. So the operating system will perform resource abstraction or virtualization. You may have heard about the concept of the abstraction, right? I'm gonna explain the concept of the abstraction in more detail later. And also the operating system, it uses the computer hardware resources in an efficient and safe manner. So we have to schedule some jobs, tasks, and CPU and memories for the efficient computation. And we have to protect some data to protect some data from for the security issues. So then, to accomplish the goal of operating system, let's see what operating system do. From the application or user view, computer users want the use of the computing resources, right? So they don't want to care about the complicated operations and details of the hardwares. They just want to use the computer easily. So the operating system will provide an abstract view of the underlying computer systems. At here, the abstract view means a simplified view of a complex system. We have learned about how the central processing unit, CPU, works, right? They perform some pipelining, branch prediction, or they also have very complicated ISA, right? However, when users use the computer, the user do not have to care about the details and the complicated operation of the CPU, right? That is the core concept of the abstraction. So to make the user can easily use the computing resources, operating system will provide this kind of abstracted view to users. So, for example, we have storage, input-output devices, and networks. The operating system will hide the details of these hardwares and offers files to users, which is very abstracted view and the simplified concept of these hardwares. So user can use these storages, I/O devices, or networks easily through this abstracted view of the hardwares. And at here, let's see some examples of the I/O devices. So this means input and output, and we have many I/O devices like keyboard, mouse, display, and also disk like HDD and SSD, and even Bluetooth, Ethernet, or Wi-Fi. All the inputted, all these stuffs are included in the I/O devices. And today we're gonna see some examples of how the operating system handles keyboard, mouse inputs, and also disks. And from the system view, operating system deal with many applications and users. They compete with each other for resource use. So we have many users and we have many applications, and they want to use the same CPU and same memory. So they will compete for that. And from the system view, they have to manage the resource. So the operating system will allocate and manage the various hardware resources such as CPU, memory, or I/O devices to allocate this kinds of resource to users or programs. So we have to solve this the conflicts from the competition, and we have to decide how to share the resources to users and applications in efficient and fair manners. Also, operating system will control the execution of programs to prevent errors and prevent improper like attacking use of the computer. So to do these steps, operating system provides some services. They provide functions such as user interface, and operating system also support program execution, like load a program into memory and run the program, or they handle the operating system handles I/O operations like keyboard mouse inputs or a disk read and write. Also, operating system manipulate file systems, and they support communications. At here, the communication means the communication between programs, like among the processes, not between humans. So operating system will handle the shared memory through the processes, and also they support the error detection to resolve the errors on the bugs. So yeah, and another set of the operating system functions, it's make the efficient operation of the system itself. So operating system provide a service such as resource allocation. So when multiple users or multiple programs run concurrently, operating system will schedule their requests and allocate the resources. And also operating system track the use, which users use how much and what kinds of resources. So it performs accounting, and as I told you before, OS also protects some security data or etc. Okay, do we have any questions so far? Today's topic is not difficult, right? Okay. Then let's see how computer systems work, especially focusing on I/O devices. Let's see computer system organization. Modern computers consist of CPUs, device controllers, and all the devices are connected through a bus. So in this picture, these things are the devices, and we have device controllers. So it's a hardware. These stops are hardware, and these stops are software. So in OS, it's a kind of a device driver. So OS will handle these device controllers. And in this picture, this black line are the bus. So bus is a sort of a wire that transmit data. So we have bus controllers and CPUs. So we have multiple hardware devices. So and they will run concurrently, right? And the concurrent execution will be handled through the CPUs. So disk wants to use the memory, and keyboard or mouse or even printer wants to use the memory. So the CPU will handle this, all these hardwares and all the device controllers to handle the compete for the memory cycle. And I'll give you an example how the CPU and the device controller works. So in this picture, we have 3 device controllers, and each device controller is in charge of particular specific dedicated device. And each device controller has a local buffer which can store some data. So yeah, each device controller has a local buffer. And let's say that we are trying to typing some text via keyboard. So the keyboard will generate some data, and our goal is typing some text to the computer. So the text will be stored in the memory. So we have to send this data to the memory. When the keyboard generates the data, the data will be temporarily stored at the local buffer at here. I made a PPT animation which smoothly moves from here to here, but it doesn't work at here. I don't know why. Okay, anyhow, so when this local buffer saves the data, then CPU will finally move this data into the memory. So when we move this data from here to here, CPU must handle it. So IO devices cannot directly send its data to the memory. So why can't IO devices be directly connected to the bus? Why they cannot directly send the data to the memory? There are 2 big reasons. So the first one is different types of IO devices require different control methods. For example, we have keyboard and disk. Their types are different, right? So how to handle them are still different. So to handle different IO devices, we need different hardware or software to control them. At here, we have softwares. But if we want to directly control this IO devices and send their data to the memory, we have to add new circuits. So we have to add new circuits at here, also at here, at here, at here, at here, to to directly connect the IO devices to the memory. However, it is not very efficient way, right? If we have a CPU which can handle all the device controllers, we don't need separate hardware. So, and it is nearly impossible to include all the different control circuits inside the CPUs or the outside. So that is the one reason. So the device controller software will handle them instead. That is the first reason. And the second reason is that the data transfer speed of IO devices is much slower than that of the CPU. So, for example, when we use the keyboard, my typing, even if my typing speed is very fast, I cannot catch the speed of the CPU, right? However, if the keyboard, let's say that let's say we don't have a local buffer. Let's say we don't have a local buffer, and the keyboard will directly send the data to the memory, and CPU will control the how can I say? Will deal with the this data transmission process. Then CPU is very fast, but the data generated speed of the I/O device is very slow. However, in this situation, if we don't have a local buffer, we have to, the CPU have to wait for the I/O device's data generation. And this thing is very inefficient because CPU would waste a lot of time for waiting for the data data from the I/O devices. So that's why we have a local buffer, and we will wait until the local buffer to be full, and we will send the data to the memory. Yeah, so that's why we cannot directly connect the I/O device to the system bus or main memory. Any questions so far? All right. And we will call this method as a polling. So let's see the very basic way to approach to send the data from I/O devices to the main memory. The first one is programmed I/O, aka which is called polling. So in this approach, CPU will repeatedly check the state of an I/O device through a device controller, and it will wait for the I/O device to generate the data. If the state is ready, if the I/O device generated on data, then CPU will directly move the data to the main memory. But in this approach, CPU must always be involved in I/O operation handling. So CPU is very fast, and I/O devices relatively slower. And in this approach, CPU resource can be used very inefficiently. And CPU may waste substantial time waiting for the I/O device, and we call this approach as a busy waiting. So when we want to perform the I/O operation, CPU will busily waiting the I/O device, and it cannot perform other things. It is not good. It is not efficient, right? CPU will waste the time. So to this end, to solve this issue, the modern computer operating systems use the interrupt-driven input-output. So at here, device controller will notify the CPU to the when the event is generated, and we will call this notification as interrupt. So, like the previous example, let's say keyboard. We use a keyboard to generate the data. The data will be stored at the US controller's local buffer, right? Then, when the buffer is full, and at that time, the USB controller will make an interrupt to the CPU. So, in this example, CPU is not waiting for the I/O device. So, before this interrupt, CPU will do some other program. Will run the other programs, and when the interrupt is occurred, then CPU will stop the other running the other program, and it will, after the interrupt, the CPU will handle to move this data to the main memory. Yeah. after the interrupt, the data will be moved into the main memory. So in this approach, CPU can run other program even if input-output devices generate the data. And so let's see how the interrupt handling process works. So let's say a program, a CPU is running a program. So during the program execution, some hardware or software will generate the interrupt. When the interrupt is generated, then CPU will stop running the current program, and will preserve the current state of the CPU. During running this program, CPU will use the registers or some memories, or the program will be run as some specific address, right? So before stopping the execution of the current program, the OS will save some the register values and address of the current program into the main memory to come back after handling the interrupt. So after preserving the current state of the CPU, then the CPU the OS will jump to the dedicated interrupt service routine called interrupt handler, and it will perform some things to process the interrupt. For example, in this example, moving data from here to here, and after completing the interrupt service routine, then it will return to the last state, which is stored at the main memory, and it will resume the execution of the program, running the program. So in this way, CPU doesn't need to wait for the I/O device, and we can efficiently use the CPU. So our modern operating system is interrupt driven, and we have two types of interrupts. The first one is hardware interrupt, which is generated by hardware devices such as I/O devices. And we also have some software interrupts. A good example of the software interrupt is division by zero. So when the program try to divide some numbers, we try to do some division by zero, then software error will be occurred, and this software will generate an interrupt to the CPU. So let's see this example. Let's say CPU is running a user process, and at that time, here, I/O devices finish the data transfer to the local buffer. And at here, the I/O device will generate interrupt, and after this time, operating system will preserve some current state of the CPU, and after that, you will handle the I/O interrupt processing. So the execution of the user process will be stopped at here, and after the interruption, it will resume the user process. Okay. So interrupt-driven I/O is a way efficient than the programmed I/O, because CPU doesn't have to do the busy waiting. It can perform some other steps. However, CPU's burden increases when moving a large and many data. So let's say we want to move some large and many data from disks to the main memory. To move the large data, it will generate a lot of the interrupts, right? because the data is many and large, we have to generate plenty interrupts. And because during the interrupt process, we have to preserve the current state to the main memory, and also we have to restore the saved state of the CPU. And it is time consuming, right? The register is very fast, but main memory is relatively slower. So these lots of interrupts will slow down the CPU, and it is not efficient. So CPU can still be used inefficiently. So to solve this issue, we have a new hardware called direct memory access. And to send the large data, we will use this direct memory access I/O. So this approach requires a specific hardware for handling I/O operations, which is called DMA controller. When the CPU requests, when we want to move the large data from disk, CPU will request an I/O operation to a DMA controller. So DMA controller will move the large data into the memory. And yeah, so DMA controller from the data transfer between this is device controller. Between device controller and main memory without the intervention of the CPU. And after the data transmission, the DMA controller will notify the CPU of the end of the I/O operation by generating an interrupt. The benefit of the direct DMA is the CPU can perform other tasks while an I/O operation is being processed. So it can be used high-speed I/O devices to transmit information at close to the main memory speeds, because it will not generate the interrupts. Then let's see how the DMA I/O works. We have two examples: write operation and read operation. Okay. So the core of the read operation is reading the data from the disk and move the data from disk to the main memory. Firstly, CPU will initialize the DMA controller. The CPU will set its mode to the DMA mode read. And after that, CPU will give the location, the buffer, the dedicated address of the main memory and the dedicated size of the buffer to the DMA controller. Third, DMA controller requests the data transfer from the disk controller. So this DMA controller will request this disk controller to give the data. Then this controller will send the data, will read disk and send the data to the DMA controller bytes by byte. And after that, the DMA controller will write the data will be handed to the DMA controller, and the DMA controller will write the data into the corresponding buffer, which is located at address X. And after each transfer, the DMA controller will reduce the value of the C. The C-1, C-2, until C becomes 0. And when the C becomes 0, the data transfer is completed. So the DMA controller notifies the CPU via an interrupt, saying that the data transmission is completed. Any questions? today's content is not quite difficult, right? The write operation is very similar. The CPU also initialize the DMA controller to set the mode to DMA mode write, and DMA controller gives the buffer address and X and the size C. So in this example, we will copy this data into the disk. And third, DMA controller checks whether the disk controller is ready to write. So we have the we want to move the data into the disk specific location, right? So the disk controller will check the address is available or the disk is empty. So after the disk controller checking, the DMA controller reads the data from this main memory buffer, and it will send to the disk controller. And so DMA controller will read the buffer and decrease the size C by one, and it will continues until C becomes 0. When C becomes 0, the transfer is completed. So likewise, the DMA controller will notify the CPU this data transmission is completed via an interrupt. So yeah, that's all for the direct memory access. Nowadays, DMA is studied for the AI data centers or GPUs to directly send some data from GPU to some the memory or the server to server. But if you are interested in this technology, you can search for RDMA or etc. Okay, the last topic. The operating system supports multi-programming. So the multi-programming is locating multiple programs at main memory and use them concurrently. So it is one of the most important aspects of operating system. So it will enable the system to run the multiple programs at the same time. So why do we have to support the multi-programming? So multi-programming is needed for the efficiency. A single program cannot use the CPU and I/O devices all the time at 100%. So let's say a program A is running. At some time, it will use the CPU, and at some time, it will wait for some I/O devices or some other stuff, so it will be idle. And you can use the CPU again and again. And at this time, when the program running the program A is idle, the CPU will not be utilized. So if we use the multi-programming, we can run other program at this time. So using the multi-programming can increase the efficiency of the CPU utilization. It can increase the CPU utilization. So multi-programming will organize the jobs so the CPU always has one to execute. So it will prevent the CPU to be idle. So the main memory will store some programs or jobs in the main memory, and one job will be selected via the job scheduling. Yeah. So when program A is wait for some I/O devices, operating system will switch another job to CPU not to be idle. So this multi-programming will enhance the efficiency of the CPU utilization. That was the multi-programming, and let's see multitasking. So the multitasking is the extension of multi-programming. So unlike the multi-programming, the CPU switches jobs frequently, so the user can interact with each running job. So in this example, each job is given a time slice. So let's say time slice is 1 second. So in this multitasking, job 1 will be executed as much as 1 second, and after the 1 second, the job 2 will be executed, and after another 1 second, then the job 3 will be executed. So by performing the multitasking, every jobs will be frequently switches, so the user can interact each job very responsibly. So it enables the interactive computing. And for the responsiveness, response time should be lower than the 1 second. So modern operating system, every operating system supports this multitasking, and there are more details behind this multitasking. For example, the given time slice can be diverse. So in Linux kernel, we have a completely fair scheduler, or some parity utilization, or some CPU governors to handle these time slices and priorities. But we will cover the details of this multitasking and job scheduling before the final exam. But the contents of that part will not appear on the final exam. So let's see the tentative schedule. So at this week, I think I can cover some details about some completely fair scheduler or some CPU governors. Okay, then that's all for today. Yeah, I have one more slide. So we can compare the multi-programming and multitasking in visual ways. So in multi-programming, when a job or a task A will be idled, then another job B can be executed to prevent the CPU idle. However, in multitasking, we will slice every jobs into the given time slice, and we'll alternately execute the multiple jobs. Okay, that's all for today. Do you have any questions related to today's topic? Okay, then before ending our class, let's take the survey. 기말고사의 시험 범위 중간고사 범위를 포함하나요? The question was the final exam will cover the contents of the midterm exam. The answer is no. You don't have to study SIG to prepare the final exam. DMA와 MM의 역할이 어떻게 다른지 알려주세요. Please distinguish the details of the DMA and memory management unit. I will cover this question in the next class. Yeah, today's contents will be included in the final exam. 한국어 강의 the Korean the Korean class lecture was failed to record it. So there was a computer error to record the previous lecture. 기말고사 점수 기말고사? 기말고사 점수 언제쯤 나? The midterm exam score will be announced next Monday. Okay, then that's all for today. Enjoy your weekend.